Bismillahirrahmanirrahim. Today we will discuss about exercise 6.1 of class 9 mathematics. Question number 7. That is, if x plus 3 into x minus 2 is the HCF of two polynomials. First is p of x is equal to x plus 3 into 2x square minus 3x plus k. And the second polynomial, that is p of x minus 2 into 3x square plus 2x then 7x minus l. And find the value of k and l. You have two polynomials here. First is p of x and the second polynomial is q of x. And also we have a condition, that is if x plus 3 and x minus 2 is the HCF. HCF means factor, highest common factor. If it is highest common factor, then it must be a factor of both of these polynomials. Mean to say, if we are going to divide x plus 3 to this or x minus 2 to this, then our remainder must be 0. So we have two unknown values in it. First is the value k and the variable l. So we need to find the value of k and value of l in it. If we have the condition that x plus 3 and x minus 2 are factors of both of these polynomials. So one by one we will solve these polynomials. First of all, we will solve the polynomial p of x. And in p of x polynomial, we can see that we have an unknown variable, that is k. So we will find the value of k from here. How we can find it? Just see that the first polynomial, that is p of x plus 3, 2x square minus 3x plus k. Now we have two factors in it. First factor is x plus 3. Second factor is x minus 2. Either you can use this one or this one. But in this situation, we need the factor through which we can easily find the value of k. First, we can use this x plus 3. Apply 0 method here. Put x plus 3 is equal to 0. As we have already done in exercise 5.3 and 5.4. So, for value of x, that is minus 3. But what if we are going to put this value of x? Just see, put this value of x in it, then you will get, instead of x, you have to write minus 3 everywhere. Minus 3. Instead of x, I am writing the value of x, that is minus 3. And then plus 3, and then 2 into minus 3 square, then minus 3 into minus 3, and then plus 3. Now you can see what will going to happen here. Minus 3 and plus 3 answer is 0. So if this is 0, then 0 multiply. This 0 is going to multiply to all of them. So if this is 0, then this is going to multiply to all of them. 0 multiply 2 into minus 3 square, that is 9. Minus into minus, that is plus. 3 3 is 9 and then plus 2. You can see that 0 will going to multiply to all of them. And we have left with no value except 0. How we can find the value of k here? Even the k will be 0. So this is not true. So this factor will not work. Also it can work because it remains the value 0 because it is a factor. But our requirement is to find the unknown variable. So the unknown variable here is k. So this not works. Now we will try this factor. So this was just for demonstration. You need to verify without solving this. You can see that if I am going to apply this one, x is equal to this plus 3 will be minus 3 there. So this minus 3 and plus 3 will be 0. So this is not true. This is not a good thing for to find the value of unknown variable present in it. So we will apply this x minus 2 is equal to 0. So after you can apply this value, you can't get the value 0. Okay. So the value of x here is that is 2. Now put it inside this polynomial and you can easily get the value of this k. So apply this value t of this x. Instead of this x we are writing 2, then 2 plus 3 and then 2 into again 2 square, then minus 3, then 2 and then plus 3. Now I am writing here t of 2 instead of t of 2 I am writing this 0. Now think about it. Why I am going to write this thing as 0? I have already told you that these are the factors. Factors means its remainder will be 0, its answer must be 0. So I am writing this 0 because told me that it is the HCF. HCF means the highest factor. Highest factor means possibly the factor. So for factor we have left with remainder 0. So I am writing this 0. After that 2 plus 3 that is 5 and then 2 into 2 square. 2 square means 4. 4 multiplied by 2 that is 8. 8 minus 3 to the 6 and then plus 2. Now see that now we will left with the value of k and we can easily find it. So 0 is equal to 5. 8 minus 6 means 2. 2 plus k. Now 5 will going to multiply inside. So 0 is equal to 5 to the 10 plus 5k and then 10 will going to be subtract there. This is positive 10 and will be negative there is equal to 5k. After that you can easily get the value of k because this 5 is multiplied here and will divide on the other side of the equality. 5 1s are 5, 5 2s are 10. So the value of k here is that is negative 2. We are done with this value of k. Now we have to find the value of L. We can see that the value of the L variable presented that is in this variable, this polynomial u of x. So now we will solve this polynomial u of x. Now for q of x, 3x squared plus 7x minus L. Now you can realize that which factor we are going to use. Either we can use x plus 3 or either we can use x minus 2. Both are the factors, but we need the factor through which we can get easily the value of L. So if we are going to apply this one, x is equal to then 2, then 2 minus 2 will be 0, and we can't get the value of L. So we will use this. X plus 3 is equal to 0, and then the value of x that is minus 3. So put this value q of minus 3 is equal to Instead of writing x, we are going to write the value of x, that is minus 3 and minus 2, and then 3 into minus 3 square. After that, plus 7 into minus 3, and then minus 7. Now, we are going to write instead of minus 3, we are going to write here 0. This is 0 just because of this is the factor, x plus 3 is the factor. So minus 3 and minus 2, that is minus 5. 3 into minus 3 square means positive 9, plus into minus, that is minus, so 7 into 3, that is 21 minus 12. So 0 is equal to minus 5. 3 minus 27, 27 minus 21. That makes 27 minus 21, that makes 6 minus L. Now, minus 5 into 6, that is minus 30 into plus 5L. So, minus 30 will be here, and 30 is equal to 5L. 5 ones are 5, and 5 6 are 30. So, we are left with this value, that is L is equal to 6. So, you can see that how we can easily get the unknown variable values, that was K and L. This was your question number 7. Now for question number 8, for HCF and LCM, one formula you need to know about it, that if we have two polynomials, suppose first polynomial is P of x and the second polynomial, that is Q of x, any two polynomials, then their multiplication answer must be, you need to be very careful about this formula. If I'm going to multiply both of these polynomials, then the answer must be equal to the HCF of them and the LCM of them. And that's it. Again, I'm telling you, if we have any two polynomials, first is P of x and second is Q of x, and we have found the HCF of them and also the LCM of them. I have already told you all the methods how we can find the HCF and how we can find the LCM. So their HCF and LCM multiplication answer will be what? The P of x and Q of x multiplication answer. That's it. Okay. So this is very simple formula. First polynomial multiplied by second polynomial is equal to HCF and LCM of their multiplication of them. So you need to know about this very easiest formula. This will apply here in question number 8. So the question number 8 here is, open your books and on page number 120, read the question number 8 statement, that is the LCM and HCF of two polynomials P of x and Q of x. You can see that four things are used: LCM, HCF, and two polynomials P of x and Q of x are 2 into x raised power 4 minus 1. What is this? This is respectively LCM. Our LCM value is the LCM and HCF of two polynomials P of x and Q of x are 2 into x raised power 4 minus 1, and HCF, that is x plus 1 into x square plus 1 respectively. Some of students are going to confuse that how we can find that this is LCM and how we need to know that this is HCM, because the statement, in this statement you can read now the LCM and HCF of two polynomials P of x and Q of x are this and this respectively. Respectively means first number, first value will be of this first written value and the second will be of second written value. LCM is this and HCF is this. HCF and LCM are here. Now we need to find P of x and what is Q of x. So further thing, if P of x, that is P of x here is x cube plus x square plus x plus 1. This is P of x. Then find Q of x. So we have this formula. You have already done these type of formulas. If we have four things, 1, 2, 3, 4, in any formula, then we need to find one thing. If we have already three values, then we can easily find the fourth value. So we have 1, 2, 3, three values, and we need to find the fourth value, that is Q of x. So through this formula, we can easily find the Q of x that is there. So apply this method. The formula is, we know that P of x multiplied by Q of x is equal to HCF multiplied by LCM of them. Now, to find the value of Q of x is here. This P of x is multiplying and will be going to divide. On the other side of equality, multiply by LCM here, and P of x will be going to divide there. Now we can easily find the value, the polynomial, that is Q of x. So now put all the values in it. Q of x is equal to HCF. What is HCF here? HCF here is 2 into x raised to the power 4 minus 1 multiply. What is LCM? LCM is, sorry, HCF is this. You can easily see. HCF is x plus 1 into x square plus 1. And LCM, that is 2 into multiply sign and then 2 multiplied by x to the power 4 minus 1. And in denominator, P of x, that is x cubed plus x square plus x plus 1. Now, some of the students will confuse that how we can divide them. You can divide them with many methods. But if you have some factorization procedures, you can easily get this point. You can see that this and this x raised to the power 4 minus 1, this expression and this expression, we can easily express it in the form of factorization. How? You can see that this is x raised to the power 4 minus 1. I'm solving here. X raised to the power 4 minus 1. This is the formula. I hope you can easily see this here. X raised to the power 4 minus 1. This x raised to the power 4 minus 1. Now think that which type of formula it is going to be made here. We have already knowledge that a square minus b square means between two squares, if there must be some negative sign, then it can be the formula. That is a plus b into a minus b. How we can make this formula? Ignore both squares on it, and first you have to write with addition sign and then you have to write with subtraction sign. So this is also this formula. Between these two squares, X raised power 4 is square of x square. So you need to write that x square and then minus 1. 1 is square of 1. So you can say that this is a square and this is b square. Beneath this square, this is a, and beneath this square, this is b. So you can easily do this. This must be a plus b into a minus b. So value of a is beneath this square, that is a. X square, not x, because beneath this is x square. So x square plus 1 in the form of positivity, and then you need to write it in the form of negative. X square minus 1. So we have done with its factorization. And for this one, we can easily do this. I'm writing here x cube plus x square plus x plus 1. These are 4 expressions with positive sign between them. So for 4 expressions, you can easily do it. What will be common here between them? You can easily see that x cube and x square. So if we are going to take common the variable, then we can take common the lowest power. With respect to lowest power, we can take common x cube, and this is x square. The lowest power is x square. So we can easily take common the lowest power, that is x square. So x square, and after that x square is outside here and it is left with x raised power 1. So x raised power 1 here, after that plus sign, and this x square is outside here. So we are left with 1 here. So 1 will be here. After that, what about these two values? Nothing is common here except this plus 1. So plus 1 you need to write here. After that, nothing is common, so you can easily write x. If 1 is common, then you need to write each and everything as it is. Now you can see that between this bracket and this bracket, what is same thing? X plus 1 and then again x plus 1. Then you know that what we need to write is x plus 1 time and then x square plus 1, and that's it. So without division, we can easily do this. Q of x is equal to then x plus 1, then x square plus 1. After that, multiply sign, after that 2, and then instead of writing x raised power 4 minus 1, we can write x square plus 1 and x square minus 1. So x square plus 1 and then x square minus 1. And in denominator, instead of writing all these values, we can write its simplified form, that is x plus 1 into x square plus 1. So you can easily see that we can cancel this x plus 1 with this x plus 1, this x square plus 1 with this x square plus 1, and we are left with only this q of x value, that is 2 into x square plus 1 and x square minus 1. And that's it. This was your question number 8. You can see that how we can easily find the unknown variable value. Okay. So for next question, that is question number 9. For question number 9, it's just like the same question. That is, if we have p of x, let p of x, what is p of x? The given value is 10 into x square minus 9, and then x square minus 3x plus 2. This is all the first polynomial, that is p of x. And after that, for q of x, that is 10x into x plus 3 and then x minus 1 whole square. This was q of x. And after that, if the HCF of p of x and q of x is, so we are left with HCF. The value of HCF is given, that is 10 into x plus 3 and x minus 1. We need to find the LCM. So how we can find this? We can again use that formula, p of x multiplied by q of x is equal to LCM multiplied by HCF. So we can say that we know that HCF, or we can say that p of x multiplied by q of x is equal to LCM multiplied by HCF. So after that, now you need to find the value of this LCM. So this LCM is here and HCF is multiplying and we're going to divide there. So we can write it as P of x multiplied by Q of x divided by this HCF here is equal to LCM. Now we need to put all the values in it. So LCM, I'm writing here, is equal to equal sign and then put all the values in it. What is P of x? That is 10 into x square minus 9 and then x square minus 3x plus 2. After that, we have multiplication sign and then q of x, that is 10x, then x plus 3 and then x minus 1 whole square. And in denominator, HCF. What is HCF? That is 10 into x plus 3 and then x minus 1. So you need to divide them after making factors of it. First of all, you can easily divide this 10 to this 10 and then this x minus 1 to this x minus 1 whole square, then we cut it and it left with the power 1. So what about this x plus 3? This x plus 3 cancels this x plus 3 and rest is your LCM. So your LCM is x square minus 10x and then x square minus 9 and then x square minus 3x plus 2. And that's it. This was your LCM. You can easily find the value of any unknown variable or any unknown between these four. So you can easily get it. After that, for question number 10, that is, let the product of LCM and HCF of two polynomials be. Now, in this question, he's providing the product answer, not LCM and HCF separate values. After making its product of LCM and HCF, product means multiplication. So we can write it as LCM multiplied by HCF. Product of LCM and HCF. This answer is what? That is x plus 3 whole square, x minus 2 and x plus 5. After that, if one polynomial, you can say that first polynomial, that is p of x, P of x is x plus 3 into x minus 2. And the second polynomial Q of x, that is x square plus ax plus 15. Then you need to find the value of k here. You can see that we have every value in it. LCM multiplied by HCF, P of x and also P of x. But one thing that is unknown, which is this k. So we need to find only the value of k here, and that's it. So we know that LCM multiplied by HCF is equal to P of x multiplied by Q of x. Now put all the values in it. LCM multiplied by HCF, that is this one. X plus 3 whole square, x minus 2 into x plus 5. After that, this equal sign. And then P of x, that is x plus 3. And then x minus 2. After that, multiplication sign, and then Q of x, that is x square plus ax plus 3. Now you can easily see that this is x plus 3 and this is also x plus 3 whole square. You can cut it directly, or you can say that k is here. So these values are multiplying and we're going to divide on the other side of equality. So you can write it as x plus 3 whole square, x minus 2 and x plus 5. After that, these are going to be divided here, x plus 3 and then x minus 2 is equal to x square plus 3x plus 50. So divide them, cancel them, x minus 2 with this x minus 2 and 1x plus 3 will cancel this, only 1x plus 3 and 1x plus 3 will left here. So this x plus 3 will going to multiply to this x plus 5. So after multiplication, we can get this as x will going to multiply to this x plus 3 into x plus 5 is equal to x square plus ax plus 15. So multiply both of them, that is x square plus 5x plus 3x plus 3 5s are 15. You have very well knowledge about algebraic multiplication from class 5, 6, 7, 8 is equal to x square plus ax plus 15. Remember that we need to find only this value of k here, and that's it. So this is x square, 5x plus 3x makes 8x plus 15 is equal to x square plus 3x plus 15. Now this x square, and if on the other side of this equality this is x square, you can cancel them. This is 15 and on the other side that is also 15, you can also cancel them 15 with this 15. So you are left with only 8x here and kx here. So you can easily get that this x is multiplying and will be going to divide here and then cancel with x to this x, or directly you can cancel this x. So you are left with the value of k. The value of k here is just 8. This was your question number 10. In the next lecture, we will discuss about question number 11 and the other exercise, that is exercise 6.2. Now, if you have any questions regarding today's lecture or regarding previous lecture, you can ask it now.